Hey guys, so this is going to be a couple of examples of what you're going to need to know and be able to do from 4.7 on inverse trig functions. You're going to be evaluating some of these trig functions for finding an angle. So when you see cosine inverse of -1, what we're looking to find, what I'm asking you to find is an angle that gives you a ratio. Cosine again is adjacent over hypotenuse that's equal to -1. So again, cosine, a couple different ways to think of cosine. Cosine is of an angle is equal to the side adjacent over the hypotenuse. It's also equal to x over r in terms of x, y, and r. Okay, so and again, the cosine graph starts at its maximum. It has a period of 2 pi. Let me get rid of this. And so 2 pi units later, you're back up here at 1. Halfway in between, you're going to be at the minimum of -1. And we have pi over 2. So every multiple of pi over 2, it goes from a max to a middle to a minimum to a middle to a max. And it looks spelled like this. So if we're trying to find what angle makes the cosine's output equal to -1, it's right here along this line, and there would be, because the domain of the cosine is -infinity to infinity, and you could continue this graph forever, you have actually an infinite number of places where it equals -1. But we're going to be looking for, when we're looking for the inverse trig output, that I want you to match the output that a calculator would give. So remember, your calculator is going to restrict the answers for cosine between 0 and pi. For sine, it's between -pi/2 and pi/2 inclusive, and for tangent, it's -pi/2 to pi/2, not including pi/2 or -pi/2. So the only place where the cosine is equal to -1 is at pi. So that means that cosine inverse of -1 is going to be pi radians. And again, it'll be equal to -1, 2 pi units, every 2 pi units from that value of pi. So there's actually an infinite number of answers, but this is the answer your calculator would give you if you're in radian mode. Okay, number 2 here is arctan of 0. So what angle gives you an output of opposite over adjacent of 0? And that is to be continued. Okay, so I'm back. I had to take a long pause because I had a class in between. So I forget where I was exactly, but it looks like we're on number 2. We're going to find the arctan of 0. That means let's find what angle. So another way to write arctan is you could write tangent inverse like this of some angle theta or x, whatever you want to call the angle measure, which is what we're trying to find, equals 0. So what angle would make the opposite over the side adjacent equal to 0? Well, a fraction is equal to 0 when the numerator is 0, which is when the side opposite is 0, which is when you have an angle that is 0 degrees. And if you think about the graph of the tangent function, so we did this, we started out, we were thinking of the tangent as the identity sine over cosine. So if we have, it's in a different color, if we have tangent of an angle is equal to sine over cosine, that is a quotient identity. It's 0 when sine is 0, which is at 0 degrees, and it's undefined when the cosine is 0, because it would make the denominator 0, which you can't have. And so you end up with these asymptotes at every multiple of pi/2. Tangent graph looks like this, and it keeps repeating, but the principal branch is where you make the tangent function 1 to 1, so it's inverse the domain of the 1-to-1 function is between negative pi over 2 and pi over 2, so that becomes the range of the inverse. So when you're looking for tangent of 0, we're looking for an angle that's in between negative pi over 2 and pi over 2, not including those values because you'll have 0 in the denominator at those points. So the graph of tangent inverse, if I reflect all the x and y ordered pairs, instead of staying between two vertical lines at negative pi over 2 to pi over 2, they're going to be horizontal lines. And so instead of vertical asymptotes, we have horizontal asymptotes. That's supposed to be a dotted line. And the graph looks something like this. And it gets closer and closer to that horizontal y value of pi over 2 as x goes to positive infinity, and as it goes to negative infinity, it's getting closer to negative pi over 2, but it never actually gets there. So anyway, we're trying to find the tangent of what angle gives us 0 in this graph right here, and the only one is this one right here. So tangent of 0 is 0. Okay, next one. Tangent inverse of negative 1. So now we're looking for what angle gives you a ratio of opposite to adjacent that is 1-to-1, but it's negative 1. And it has to be a measure between negative pi over 2 and pi over 2. So I want you to stop the video and try to figure that out, and then come back and check your answer. So at negative 1, so let's say negative 1 is about here, positive 1 is about here. What angle, tangent of what angle gives you a ratio of 1-to-1? Let's think of it as the positive first of all. Tangent of, this is what we're really finding, is tangent of what angle is going to give us, it's really negative 1, but let's start with positive 1 to make it a little bit easier. What angle measure has the side opposite and the side adjacent the same? And that angle would be pi over 4, right? The side opposite is the same as the side adjacent. I can scale it up or down, but the ratio of sides is 1-to-1. So it's a multiple of pi over 4. This angle on this side would be pi over 4. We're looking for what would make it equal negative 1. So what is this angle measure? And remember the answer has to be between negative pi over 2 and positive pi over 2. And the solution is it's negative pi over 4. So the answer to this third one is negative pi over 4. All right, and there are actually multiple, let me go through this. I want to just make sure everybody's understanding this. So the graph of tangent, let's start with like the tangent graph instead of the inverse. We have an infinite number of branches. I'm going to do the actual graph in a different color. So I just drew my asymptotes, and the graph actually is this green graph, and it repeats over and over and over like this. It keeps going forever. So if we're looking at like, let's say this is at negative 1 and this is 1 up here. If we're looking for where does the tangent of what angle equals negative 1, well, if I draw a horizontal line through negative 1, oops, that's not quite going through negative 1, like that, there are an infinite number of solutions. There's this one, there's this one, this one, this one, and this one. But what we talked about the other day is that your calculator is only going to find the one that's in between negative pi over 2 and pi over 2. Because remember, we had to make the graph 1-to-1, so we had to restrict the domain. So we took away all of these other branches so that we could graph a function when we graph the inverse. which that looked like, oops, wrong direction, this graph. I'm going to graph the inverse. So the angle that's in that region between negative pi over 2 and pi over 2 is negative pi over 4. All right, so let's do, so the nice thing is if you're finding the sine inverse of positive 1/2 or any positive value, it's going to be the angle in the first quadrant that we're looking for. You might need to find a different angle, but your calculator, what your calculator is going to give you is an angle in the first quadrant. And if it's a negative, if this number over here is a negative value, then it's going to give it to you in a different region depending on the restricted range for the inverse trig function that you're dealing with. Okay, so find sine inverse of 1/2. Again, what you're finding, and all of these you should pause it and see if you can do it, but then come back and check. What you're finding here is sine of what angle, I don't know that, so I'm putting in theta because I don't know what it is going to give you the ratio of 1 to 2. And actually you guys did a worksheet like this in 4.2 several weeks back. So you've already been doing this, but you got to think about what angle will give you a ratio of 1 to 2. And hopefully you're starting to memorize some of this stuff. The answer is, in degrees, it's a 30-degree angle. Lots of different ways to think of it. Right triangle, unit circle, periodic function. But the sine of 30, 60, 90, if you look at the ratio of sides, is 1, 2, square root of 3. Again, you can scale it up or down, but the ratios will still be the same. The sine is the side opposite over the hypotenuse. So opposite is 1, hypotenuse is 2. So 30 degrees, if theta is 30 degrees, you end up with a ratio of sides of 1 to 2 on the opposite and hypotenuse. So this is 30 degrees, or in radians, that would be pi over 6. Oops. Okay, I have another one here. So cosine inverse of square root of 3 over 2. What I would suggest that you do is find cosine inverse of positive square root of 3 over 2. Find the one that's in the first quadrant, and then think about what the cosine inverse is restricted to. And then come back. Okay, so if you look at the cosine inverse of square root of 3 over 2 in the positive first quadrant, you would have, we want to figure out where the adjacent over the hypotenuse is square root of 3 over 2, which is, again, the 30-degree angle. But we're going to talk radians, so it's pi over 6 radians in quadrant 1. But when you look at the cosine graph, remember we restricted our domain from 0 to pi so that we make the cosine graph 1 to 1 so that its inverse is a function. Graphing the inverse, you're going to switch the domain and range. This is going from the point 0, 1 to pi comma negative 1. And so my domain is, restricted domain is from 0 to pi. The range is going to be from, it's going from negative 1 to positive 1, the y values. So those are going to flip when you're talking about the inverse. So I switch the domain and range. The graph looks like this. If I switch all those ordered pairs, it's roughly like that. And so I'm trying to figure out the negative answer that corresponds with in the positive first quadrant, it's pi over 6 radians. So like pi over 6, I don't know where pi over 6 radians would be, but, or right here. It would give you square root of 3 over 2, which is like 0.7, so it's probably more like here. Down a little bit lower. So in the negative direction, that's pi over, it'd be about, oops, hang on one sec. Okay, I kind of messed that up and went the wrong direction. If the square root of 3 over 2 is roughly 0.8, so if I go up, that corresponds with an angle measure of pi over 6. But if I go on the opposite side, we're finding what this angle is right here, which is in actually between pi over 2 and pi. which is on the unit circle.